In this chapter, we'll look at interior lighting technique using global illumination methodologies. Certainly, GI has been a major revolution in the field in the past few years, and it has great import to digital sets and backgrounds. The problem with it, though, is that it's an evolving area. It's very computationally intensive. We'll make your 3 gigahertz box perform like a 200 megahertz box. And as a result of that, we're always looking for workarounds to make it actually usable in production. So we'll look at 2 renders in this chapter, Mental Ray and RenderMan, and we're also only going to survey this. This is a very deep topic. The DVD we have on Mental Ray, released recently, covers this much more in depth. But I just wanted to point out some of the basic issues and workflows with the GI in these 2 packages towards interiors. So we'll look at final gathering in Mental Ray and photon mapping in that package, and then we'll look at the kind of counterpart of ambient occlusion and photon mapping in RenderMan. So we'll start by saying there's 2 areas of GI that are appropriate for interiors work, that of photon mapping and hemispherical sampling. Now, in the prior chapter of GI use with exteriors, it surrounded itself with HDR use and hemispherical sampling in the form of ambient occlusion and final gather. And that's true here, but instead of using HDRs to provide illumination in the sense that an interior space can't really see out to the outside world, we need to fill light from within, rather from the outside in. And to do this, we'll emit photons from light sources and let them fill the space and create a light transport simulation to derive our lighting from. So the act of filling the space with photons is the technique referred to as photon mapping. Hemispherical sampling refers to sampling points off of geometry and casting rays out into the environment and looking for intersections in order to create proper shading. They both tend to achieve the same end in the end, but they have pros and cons with each. Photon mapping is much faster to achieve, but it's a coarser effect. The shading artifacts it will create will be not quite as fine as far as very fine shading in crevices and so forth. Photon mapping also allows color bleeding and caustics, although some of these properties are useful in interiors, but only in some cases. Hemispherical sampling tends to be much more precise, but significantly longer to render. So long that you will probably look for a workaround in this. And luckily they both do have ways to be cached out into a cache file so that they can be referred to for successive rendering. So package to package, these techniques are similar, but they do differ in some areas. Photon mapping tends to be very similar package to package, renderer to renderer, but hemispherical sampling tends to be incorporated rather differently. In Mental Ray, it's referred to as final gathering, and in RenderMan, it's referred to as ambient occlusion. Now, in the end, the best render will be achieved from the use of both, of actually getting an additive mix of the 2, where photon mapping provides kind of the coarse solution, and hemispherical sampling can come in and provide the finer details without having to spend the time to do the coarse solution. Alright, so let's look at the Indian cave temple again as an example of some of these techniques. Here what I have is an opening at the end of the file. What I want to do is let sunlight be admitted through this and then show photon travel throughout the length of this space. What I've started by doing is I've put a point light source centered on the end, and if we look at the attributes of this light, we can see it's just a point, cubic decay rate, and then under Mental Ray I've added emit photons. And most importantly, below that, I've also added area light checkoff for Mental Ray, turning it into a larger emitter of photons, an area emitter. I've also added a spotlight facing down and looking through the spot. What this will do is admit some sunlight into the foreground and let the area fall back into shadow deeper in. Okay, my next step is to set up the render for Mental Ray, make sure that Mental Ray is chosen. go to the mental ray tab, and we can choose some defaults if you like. This is now set for production. And let's move down to caustics and GI. And we don't care about caustics here, and we also don't care to have any final gather, but we do want the GI switch enabled. And this will allow photon mapping to be calculated. So there's a number of attributes here that I won't cover in any depth, but suffice to say that there's a accuracy issue which defines how accurate the transport of photons is. The radius dictates basically the smoothing between. If we go down, we have a photon map rebuild, and what's important here is to optimize the count of the photons, and once that is arrived at, this can be unchecked, and then your successive calculations will rely on a cached amount of photons. And along with that, you would want to give a photon map name to be saved out into a map file that can be referenced thereupon. Okay, so let's close this out and look at our render from this. So photon mapping has to do a calculation on the photon count. It's in effect similar to a run-up. And once that's done, the render will execute fairly speedy. But we can see from our final result here, we see the effect of the main overhead spotlight casting the sense of sun coming in the entry, and then the bounced light, the increase ambient lighting towards the back. And we can see it does a reasonable job of shading throughout, but none of it is very precise. It's a fairly kind of murky type of GI lighting, which again, if this is continued to be adjusted and refined, we can get rid of some of the splotch characteristics to a more smoother result. But in general, photon mapping provides the basic mechanism, but again, not the finer resolution that Final Gather may add. So I've now opened up the Final Gather demo file, and the first thing about this is all the lights have been stripped out. So we have a basic blend shader and nothing else in the scene. If we go to our render globals under mental ray, and actually the first thing about Final Gather incidentally is that this enable default light must be turned off. In this case, we're going to rely on Final Gather as a lighting less solution, and without lights Maya would add its own default lighting, and we certainly don't want that. Let's go over to mental ray, and let's now go down to caustics and GI, make sure these are unchecked, and let's open up Final Gather and make sure this is checked. So final gathering can be very computationally intensive, and as a result needs to be optimized frequently. The easiest way to do this is to find the optimum final gather ray count and then use the min and max radius to optimize that, meaning that if the min max radius is properly sized, you can take your final gather rays down to a fraction of what they would be if these were held at default. So to do this, we go to a top view and we take a basic dimension, and we can see this is about 40 units or so long. And what I've done here is we take 1/10 of the scene depth, the largest dimension in the scene, divide that by 10, put that in here, and then divide the max by 10 again to reach the min. And this should be the optimum setting for most scenes. You'll also find in a lot of these ray trace attributes that things are set at 0, and what that means is that's a default setting which will either let calculations extend out, in a unbounded fashion for ray tracing purposes. A lot of these, though, can be used to optimize the render and or create different performance. So in this case, Final Gathering, remember, is a hemispherical sampling that looks out into the world. This cave structure, very little light would actually be generated from the back of the structure because it would not be seeing much of the outside world. To change, if you have, in other words, for interiors, if your Final Gathering tends to be very dark, you can use fall off stop to extend that and to begin to limit the amount of ray travel that the ray makes out. So in a sense, lightening the scene. So in this case, I've changed that from a default of 0 to 20 to give me a reasonable result. And then lastly, we have a Final Gather Rebuild switch here, which again can be mapped out to a file. to be referenced for successive renders. So the last step in setting up final gathering is to set up our environment in a non-black color. So by default, Maya has its background color set at black. We should take that to white. And I've also found this to be a useful control to take up above value of 1 and able to kind of further boost the intensity of the sky environment or the surrounding environment. So in this case, this has allowed me to push some apparent lighting into the opening of the cave. And we'll see this in the render. So let's take a look at that now. This is the photon map version. And here we have a pure final gather occlusion pass. And again, we can see it's a little brighter here than it is going back in depth, and that's again because I had the environment set to a value higher than 1. And that's just a way for me to create a nonlinear emphasis on that. But we can see that this is now much more precise shading of the surfaces. We see this is a much more accurate depiction than the photon mapping. What we can do with this though now is render this out as a separate pass, and in compositing multiply it against other passes. In this case, what I'm going to do here is multiply it against the photon. So here we have the photon map, the final gather, the two multiplied together. So if I go back between the malted and unmalted version, we can see what final gather brings to the render. And it's going to bring much more definition of shading, say down into this area of rocks. It's also going to add more definition back here in the columns and begin to attenuate some of the photons that, let's go this way, that may be bouncing up a little bit, perhaps too harshly from the floor. So again, this is rendered to taste, composited to taste in the end, and of course certainly once textures come in that will change a lot of the relationships here, but this is the basic setup for GI and mental ray. So let's move over to RenderMan next. Okay, photon mapping in RenderMan. What we'll do here first is we have the same file as before. We have a few different lights set up. We don't necessarily use the area light situation like we do in mental ray here. We still have the same downlight though for the introduction of sunlight. And then I have a few other lights used to help kind of boost the solution on this. So the first thing we'll do is we'll go to RenderMan Slim Palette, and we'll create a indirect light, and this is under Create Appearance Light, Indirect. So the indirect lighting shader provides a means to control and generate the photons in the scene. It does not emit light per se, but rather acts as a kind of a governor for the generation. So here we state whether we want photon mapping enabled. Here we have a multiplier, which proves to be very useful, another way to tint the photons. And then if we map a indirect illumination procedure here, we have the photon map generator. And if we open this up, we can specify how frequently they're created, how many photons are made. Estimator is a way to smooth them out, and so forth. Again, another multiplier to the operation here, and most importantly the samples that are used. Okay, so let's go back, and now let's create a basic light, in this case a spotlight, and I will go ahead and attach that to this particular light. Now the location of this light is very arbitrary within the constraint that it needs to see the entire world. Or the entire area that we want photons to generate within. So again, it's just a containment device for how the photons are spread throughout the scene. But again, this will not create any lighting per se. To do that, we need the addition of other lights. So here I've created another light. I've made a spotlight shader for it, and it emits photons. So the photon creation is governed by the indirect lighting shader. And then from this point forward, any number of lights can emit photons from that. And the important thing here, though, is that the fall-off must be squared in decay for photons to be enabled. On a direct light, there's no fall-off, and that's part of the constraint. Okay, so now let's look at this light, and this is sunlight. I would like some photons to come down and bounce up into this space, so I've done the same thing here. And this light emits photons, has a warm hue, and a multiplier associated with that. I also want ray trace shadows on it, because I want to get shadows, sunlight shadows onto these rocks down below. And lastly, what I'd like to do to boost the photons back into the space a bit is provide some point sources along the length of the cave. This is not unlike what we did with the cubic lights with direct lighting. But in this case, I'm just going to use them to kind of boost in and fill in a few more photons throughout the space. So if we go here, we have a point source emitting photons with a squared fall off again. So your multiplier may have to come up in value. And we also need to consider the surface to receive photons. So in this case, I've set up an ensemble to map all these surfaces to. And within the Raise tab, we have some more controls for how photon maps are treated on the surface. And in this case, we can specify what the base material of the surface may be for the behavior that we like. So as we get into caustics, this kind of plays in more. But for our purposes here, for basic environmental shading, matte will be suitable. Okay, now we're ready to look at our render from this. And here we have photon mapping in RenderMan. So we see the sunlight cast down from the main spot. We see the ray trace shadows from that. And we do get a sense of photons kind of filling the opening or the aperture of this cave a little bit. And we also have a boosting of photons as it travels back through the space down into the darker region. So as with mental ray, it may benefit you to do a hemispherical sample on this as well and use the two in concert together. So let's now look at how that's set up as an ambient occlusion pass in RenderMan. Alright, so I'm over in a duplicate scene now set up for occlusion, and I think we showed this earlier with exterior lighting. This is a very simple operation for a base occlusion pass. All the geometry is attached to a constant shader. The constant shader is connected to a color spline, which is then connected to an occlusion operation. And this is where we have our sample count, which will dictate the quality of this calculation. Also, when we go into RenderMan Globals, we have a number of controls for this under the RAYS tab, Raise tab. And this will be here. This is where we can cache it out to a what's called an ICF file to hold the occlusion information. And a number of these other attributes can help us there. Photon mapping allows us to save it off to a global map for photon mapping. Alright, so now let's look at the result of this render. Here we have the photon map, and here we have the ambient occlusion pass from the cave. And if we look back and forth, we can see again the precise nature of the occlusion is a little more apparent, but the photon mapping has a more accurate feel of lighting to it. Again, the occlusion pass is really just to create inner surface shading more than any sense of lighting per se. So I can then take that and multiply it against the photon pass, and this is what I will get. So if we look between the straight photon pass and the AO contributed pass, we get these two. And we can kind of see the difference. Again, just as with mental ray, more definition in this region and on the columns than without. Okay, so these were some basic principles of GI for interiors. We didn't go into any great depth on here, but it does show some of the basic workflow for getting started. And again, there's great discussions on all these topics online in different forums. Again, things change weekly as far as technique on this. So get started and stay informed. And it's a great, exciting area of CG right now.